Yeah, so as Charlotte said, I'm Kyle, and I'm a software engineer at Google. Actually, we're all software engineers at Google, but let's introduce ourselves real fast. So I'm Kyle, and I am a Apache Beam committer, and Beam is going to be our main topic today, aside, of course, from Flink. Um, Ken and then Yifan, if you want to introduce yourselves real quick.
Sure. I'll just jump in. I'm Ken. I'm on the Beam PMC. I guess I'm currently the chair, which is um, more of an administrative position than anything. Um, and yeah, I've been working on Beam for a very, very long time, and I've always followed Flink, and I love it. So really, really happy to be here.
Hi, I'm Ifan. I'm a Apache Beam committer, and I'm also a engineer working on the TensorFlow extended team at Google. So brief introduction to TensorFlow extended. This is a production machine learning platform that's used at Google and by other customers as well, that handles everything that is machine learning that is in the training itself. So for instance, example ingestion, example validation, model analysis, bulk inference. And because of all these tasks are basically large-scale data processing tasks, so it's all powered by Apache Beam. So TensorFlow Extended has a heavy dependency on Apache Beam for data processing, and the users of TensorFlow Extended have the freedom to run it using the various Apache Beam runners thanks to its portability. So we have users who run it on Apache Flink, but we also have people who use Spark and Dataflow and other backends as well. So yeah, I'm here to provide a bit of a perspective from a Apache Beam customer point of view.
Thanks, Yifan. So yeah, to elaborate on what Yifan was saying about Beam, for those of you who aren't familiar, Beam is a unified batch and streaming platform and a set of SDKs for writing your data processing pipelines. And kind of what differentiates Beam in this whole Apache big data open source ecosystem is that Beam pipelines can be run on different platforms. So for example, Flink is obviously the one we're here today to talk about the most. But we also have Google Cloud Dataflow. You can also run it on Spark, SAMS, and a few others. Yeah, that's kind of what sets Beam apart. As I said, you can run Beam on Flink. It's been several years in the making of development and people working hard, both Beam contributors and Flink contributors working to collaborate to put this thing together. And I think both sides have kind of learned a lot from each other. So I hope to get into that a little bit more today. And this will be a interactive AMA type session, ask us anything. So please ask questions at any time in the Q&A tab, and we will do our best to answer them. So with that, I don't believe we have any questions at the moment. So instead, I'm going to start asking questions to my co-hosts here. I'll put Ken on the spot and ask Ken, what's going on with Beam these days? What's new? It's exciting.
That is too generic. So, I mean, I think what do I want to say about that? I'll say something that is exciting to me is that I feel like Beam, whatever it was 6 years ago, started with this promise that you could use any language you want and you can run it on whatever engine you run, right? And that, it's been possible to run Beam Python on Flink for a while. But I really feel like that is becoming extremely mature, where you can use Beam SQL and all IOs that are written in Java, and it's becoming possible. You can be using Python, but you get all the connectors that have been written in Java over the years. So that's if I immediately jump to like one thing that is exciting to me in Beam right now, it's that, you know, Python and Go and Java are getting to the point where they're on equal footing and they can interact and just mix and match in a Beam pipeline on, you know, and we have Cloud Data Flow and Flink and Spark and Samza as well, all have runners that support this.
Yeah, and I won't belabor the inner workings of what it took to make that happen in this talk, because and I say we, different people who have worked on it have given multiple presentations on this. It passed Flink Forwards and other industry conferences. So if you want to go check those out after the fact, they're out there. Max Michaels did some really good ones, I think a couple of years ago. So go check those out. But yeah, it was definitely a multi-year effort, and some very heavy engineering work that went into that. So yeah, again, a product of collaboration between the two projects, which is really cool. And also another thing that I kind of want to shout out just while I'm thinking about it is that there was a talk at the Apache Beam Summit last year where Jin Chung Sun from Alibaba talked about how PyFlink is actually using a Beam internal library now, which I think is really awesome. That you know, for all these years, like Beam was running on Flink, and now PyFlink runs on Beam partly. So just a little fun fact.
Yeah, just to jump in a bit here, like the Python support and the cross-language support has always been pretty important for TFX, especially since, and also for TensorFlow users, just because for machine learning pipelines, the Python is sort of the lingua franca of like machine learning. So everyone writes machine learning code in Python, and having that Python support and the easy Python usability has been very important for us. But also we've had customers come to us and say, oh, we have existing infrastructure in Java or in other languages, and having a path to being able to support that is pretty important to us as well.
Yeah, and so to elaborate on two things there, Beam has Java, Python, and Go SDKs. There's also a third-party project called Shio that does Scala, and then we also have Beam SQL. So there's quite a little collection of languages growing there. And Beam's design means that they can all interoperate very freely. Yeah, and in particular, the Go SDK has been kind of the up and coming one. We just announced, I believe, with the latest Beam release that it's, but for many years it was in this experimental state, and we're more confident now in saying that yes, this is usable. Try it out. And it works on Flink, so it's probably the first, as far as I know, the first path really for writing Flink, or for writing Go code that runs on Flink.
There's a question in the Q&A, but before we, I also just, since you listing a few languages, we also, Kotlin, of course, works transparently with Java, so we have examples of using Kotlin. So another language you can use if that's your thing.
Yeah, so I see thanks for noticing, Ken. We do have a question in the Q&A tab. So Yashwath Ganti, apologies if I'm mispronouncing that, they ask, does the Beam community have any plans of building something to support deployments, a Kubernetes operator, for example? Today we have to rely on resources outside of Beam for this. Yeah, so I do not think that we have any plans for doing this. And the reason is that, excuse me, Beam doesn't really require too much of its own infrastructure. It's more of an abstraction layer rather than an actual like data processing engine. So, for example, we leave that to Flink or to Cloud Dataflow or something like that. So I don't think it would really make sense to write a Beam Kubernetes operator, but what we have done is we have used you might be aware that the community has written not just one, but several Flink operators. And we want to make sure that since there is, as far as I know, no official Flink Kubernetes operator, and please correct me if I'm wrong, because I'd be interested in learning about that. But there are many operators, and so what Beam wants to do is just make it so that you can use whichever Kubernetes operator you want, and then we will work with the community to help you getting Beam working on that operator. So, for example, Google Cloud Project has published a Kubernetes operator, which I can paste in the chat in a moment. But we have worked with Dataproc and worked with Flink to make sure that we can run Beam pipelines on that operator. And the same should be true for whichever Kubernetes Flink operator you choose. So yeah, hopefully that answers your question. Like as I said, I can paste a link later.
I just pasted about a kajillion links in the chat of.
Oh, perfect.
There's like a couple of GitHub repos, a couple of long form blog posts that talk through it. I'm not sure which ones are related to which repos or if they're their own thing. And then there was talk that I posted in there from the Apache Beam channel. And, yeah.
Awesome. Thanks, Ken. Yeah, and kind of just from a more like philosophical standpoint too, I think that Beam in general wants to leave it up to the user to decide what we don't want to say, this is how you will deploy Beam. We want to make sure that the users have multiple ways to do it, just so that they can conform to whatever requirements their organization and their tech stack have. So.
And I mean, there's just sort of to illustrate some of the extremes there, like Flink, there's already like many ways to deploy Flink, right? So you already need to be flexible enough to match that. And one of Beam's most unusual runners, I think, is the Twister 2 runner, where like the way that it's deployed is kind of beyond me, right? Twister 2 is like an HPC library where the runner doesn't work like the other runners, and it sort of ships pipelines around, like not in the usual, like I'm just serializing Java code and shipping it and shipping bytecode way when you're running on Java. So yeah, Beam really needs to be agnostic there because of the variety. Not just, and even within one runner, of course, this is Flink forward, even within just Flink, we wouldn't have like one way to do it.
Yeah. Very cool. Yeah, and just to keep harping on this, deployment is something that during the early days of especially Beam Python on Flink, we struggled with providing users an easy path to deployment because it does require extra components. But the thing with Kubernetes is it makes it relatively easy to just write a config file that works and then to publish it, and then other people can just kubectl apply that file and it will just set up everything for you. So it's been a pretty I would say a pretty big improvement in usability.
Let me ask you a question, Kyle, on this. So let's say somebody has written one of these, because there's a bunch of them. And I guess, so we have they're almost like examples more than canonical libraries, right? So there's an example of how this
Right.
person deploys. Would, like, if they wanted it to become, if they thought that the Beam repo, for example, was just the best place for it to live, what would you say to that? You know, I guess like my sense is a lot of open source projects, and a Beam is kind of one of them, is if somebody wants to contribute something useful and it is feasible to maintain, would we say yes? Or like, what are the considerations that go into that, right? Like, because I mean, like Beam could have, we could take all of these and just dump them into the Beam repo, right? And like, what's just,
Yeah.
I guess, how would you think about that if someone out there in the chat, for example, is like trying this? Let's say they write one, right? We don't want it to just live in their own, you know, maybe other people can benefit from them and they're not trying to manage it all themselves.
I mean, I feel fine with linking to some possible solutions from like our web page or something. But yeah, I think making it an actual part of the Beam repo, then we have to consider testing, and we have to consider, you know, we have to maintain it ourselves. So it's one of those things where the Beam repo has accepted a lot of code over the years, but I think we want to maintain quality standards. So I would say I would absolutely be comfortable with recommending, as I am, that you go check these third-party libraries out. As for actually adding them to Beam, I don't think it's likely to happen soon. But
yeah, from a customer perspective, that decoupling is a sort of advantage also, in that we have customers who already have a way of doing things. So they already have a Apache Spark cluster, or they're already using Dataflow. And being able to just integrate into that workflow with the or that deployment flow with the pipeline is a strength, rather than being prescriptive about, oh, now that you're using TFX or Beam, you will deploy things this way.
and if you're just tuning into the session, I will say it again. Please post questions in the Q&A, and we will answer them. Answering your questions is funner than answering our questions. But
So, Kyle, question for you: What upcoming features of Beam are you most excited about?
This would be, as I said, the Go SDK is very cool. Go is a very, very fun language that I've worked with in the past. And I haven't personally gotten a chance to work on the Beam Go SDK too much, but I'm pretty enthusiastic about that. Just opening the door for more potential Beam users, and kind of a new way to look at Beam, I suppose. And I also think that it's very cool that the Beam Go SDK kind of just worked on Flink without any additional effort. So, you know, we worked for all these years to get Python to work on Flink, but it turns out that once you put in the infrastructure to run Python, and by we, I'm not using the inclusive we here. Other people made sure that that was just general enough that it would apply to all languages. And so we kind of got Go support for free, which I think is really just a confirmation of kind of the design of that, and of Beam's promise to run anywhere. So many words for that. I think another thing that I'm very excited about related to Flink is doing relational optimizations, which Ken is kind of the expert on. But just to summarize, we want to integrate more tightly with Flink and the table API. Do you want to say more about that, Ken?
Yeah, I think it's sort of, I'll summarize what I think the state of things is, I suppose, right? So Beam has Beam SQL, Flink has Flink SQL, and Flink SQL has much more extensive optimization. And because it's right, they both, I mean, they're actually both based on Calcite, but Calcite's this optimization engine where you have rewrite rules that will go from your SQL statement to a physical plan of how it's going to execute. And there's limitations in Beam because Beam is abstract, where you really need, like Flink has a huge amount of runner-specific rules that optimize in ways that work well for Flink. And so there's a limit to what Beam SQL can do in terms of doing obvious optimizations that are better for any engine. So in order to get all the full advantage of the fact that you've written a SQL statement and that or just that your pipeline uses something like the table API, which Beam has something similar to it, we need to integrate with the relational capabilities of the underlying runner. And that's my spiel for that, I suppose. And Beam does support some basic stuff, right? There's Beam SQL supports like pushing down filters into some sources so that you do the processing in the relational engine, which is much more efficient because they've got specialized storage or execution models. And of course, Flink SQL does all that same stuff. Guess I don't have a lot more to say except for I think this is a really good path to enormous performance improvements, right? Because it's sort of like you're not shaving off 10%, you're just like not doing 2/3 of the work. So that's where relational has a huge amount of promise.
Yeah, and the more we can kind of integrate that with Flink too, the better it will be, because Flink has its own optimizer, as Ken mentioned, that translates I believe the table API into the data stream API. So being able to integrate with that, because right now I think what happens is Beam translates all these relational operations, but by the time they get to Flink, all Flink knows about is really just bytes. And it can't reason about bytes and it can't do anything better. But if we can translate into the table API instead, then all of a sudden Flink will be able to reason about what we're doing and be able to make optimizations that are specific to the Flink execution engine. So yeah, there's a lot of promise there.
Just to because to give an example, which I think helps me think about this, right? Beam's optimization stage will do things like take filters and push them as early in the pipeline as possible to shrink the data. Right. So that's something that's obvious, and it'd be pretty surprising if that was a bad choice. Whereas, say, when you get to doing a join, in fact, by the time the transform gets to Flink doesn't even know that it's doing a join. But Beam can do things, Beam may have the ability to get size estimates in order to try to figure out join order. But then when you're selecting a join algorithm, it's going to be implemented in terms of like the specifics of the engine, right? Like Beam has concepts of side inputs and state and timers and your general MapReduce kind of operations. But, Flink has sort of more specific, I don't actually know what, in fact, Flink has like join algorithms implemented where you could select one that's been worked on and maintained by the Flink community, like this, I think they call it a bitemporal join or something. But there's, there are, at some point you're actually choosing physical operations on the engine, and Beam can't do that. So specifically like join algorithm implementation is something where I expect getting down to the engine and allowing the engine to optimize is going to be a huge improvement.
Yep, absolutely. There's all this great work that the Flink community has done and the Spark community has done, just to name two, on optimizing the heck out of relational operations. So to be able to capitalize on that is really important for Beam. You have a question? Oh,
I see a question. Yeah, they're in the opposite order that I had. I was like, what? One at the top. Has the Flink portable render changed majorly in the last year or so? Thought it required a separate container, and I am not sure if I still see it in the documentation. What is its architecture?
Oh gosh. Okay, so the last question, what is the architecture? That's a big one that I could easily talk for half an hour about, if not more. But I will try to make it brief. Has it changed majorly in the last year or so? I would say the underlying architecture has not. What has improved quite a bit is the usability of it. Just like, you know, the class of bugs that shows up when a user goes to run something for the first time. Just to give a little overview of how this was developed in the past, we basically had one big user, one very knowledgeable user of the stack. And so we kind of fleshed everything out with them. But then there was also all these new people who wanted to get into it and were having issues because of things like containers, because of things like, you know, just random class path bugs and all this stuff. And so I think a lot of those rough edges have been ironed out over the past year or so. So, you know, there's still some rough edges, but I think the difference now is you run into some of these frequently encountered issues, and there's documentation out there. There's Stack Overflow questions. There's Beam mailing list threads that are publicly accessible that you can read about trying to debug these things. And also too, like things like the Kubernetes operator theoretically make this quite a bit easier. But yeah, to answer your second question, I thought it required a separate container. Yeah, so to be very brief, as we said earlier, Beam doesn't prescribe us one certain way of doing things. It's pretty flexible with how you deploy. So to long story short, Beam needs to have some way of running your Python or Go code. And so to do that, there does have to be some sort of environment, we'll call it, that can run the code. And the easiest way to deploy an environment, in our biased opinion, is a container. Because it lets you package all the dependencies you have and basically just ship the whole OS, which, you know, about containers, it's very handy to be able to do that. But if you absolutely can't use a container, then there's also other options available. Mostly, probably the most feasible one is to just run your Python code in a subprocess, which is a lot messier from an encapsulation point of view. But if containers really are not going to work for you, then that is an option. But yeah, if you are fine with using containers, I would absolutely recommend Kubernetes to do this, because, as we were saying earlier, being able to just run, or being able to just specify a config file that has everything set up for you already, the way it should be, in a way that won't cause problems, is going to be very handy, because I'll be the first to admit that it is difficult to get a deployment working just from scratch. Just like trying to get portable Beam set up on a cluster without any knowledge of this stuff, or without any specific instructions, is going to be a struggle. So yeah, so I would absolutely recommend following a path that has been trod before with respect to that. And Ken already posted a whole bunch of links in the chat, so hopefully those shed some light on it.
Yeah, personally for me, for development workflows, I have luck. I've been able to just run Flink clusters on in process on my local machine and not have to use Kubernetes. Probably not a good idea for deployment, but for development, if it happens to work for you, then that's at least a way to do it.
Yeah, and that's a very good point. For just getting started, there shouldn't be any containers or anything of the sort required. You can just run a Python script and it'll do all of the work behind the scenes for you. So not a major change to the internals of the Flink runner, but as far as like the end user is concerned, it makes it a lot easier. Okay. All right. I'm gonna send this one to Ken. We have a question from Jamie asks, should one of the goals here be standardization of streaming SQL? Where does that effort stand? Does a shared standard help with allowing better optimizations in the runners to be used?
Yes, is the short answer. So there is there's organization Insights that manages the SQL standard, and it takes a very long time with a lot of stakeholders to standardize anything. So there's official standardization of that sort, and then there's also informal standardization where various groups of people just start to agree and do the same thing. I'd say, so I can speak to both because I guess I'm a bit involved in both of those things. So I'll start from the informal standardization. Like we come up with some ideas for streaming SQL, like Calcite had some, and Beam sort of used them for how you express the new things you need out of streaming. And Flink, uses the same syntax as Calcite. So myself and I think Fabian Weske, who represented sort of the Flink, and Julian Hyde from Calcite, and Tyler Akidow, and there's other, and Edmund Bigoli and his and Catherine Knight from the National Research Labs, and we wrote this thing like one SQL to rule them all. It's a very sort of silly paper title, but we tried to like come up with what we thought would make sense for like what is it that I'm looking it up. What is it that streaming SQL needs, and how do we think we can, what's an approach to getting it right? And so that's the informal, like it's across many projects, many companies, many stakeholders, and just sort of trying to do some of the initial analysis. Yes, I got all of our answers. So and then we presented that, and that sort of can lead to it feeds into the process, but there's lots of other people doing streaming SQL other than us. So then Insights actually is meeting about streaming SQL, right? There's representatives from like Confluence and Google and people who and it's in the phase where a bunch of streaming SQL experts are sort of talking about their model for streaming SQL. I think Hazelcast is one. I'm not going to try to represent like everybody who's trying to weigh in on this, but so we're at the phase where there's a lot of different streaming SQLs out there, and they're trying to come up with what's the core thing we need, right? For example, we need something. Some people think we need watermarks, some people don't, right? And so do you need a concept of when an aggregation is complete, or can you express that using other constraints in your SQL query that you magically figure out are the ones you need to keep track of and map to your system's watermark and things like that. So I don't know if this is like, I'm more talking about the issue that your question raises than answering your question. I think standardization is good. Standardization of something that isn't ready is bad. And so it's okay with me that it takes a long time. And I don't think so far that sort of different perspectives are yet blocking our ability to do better optimizations. Partly because we're at the phase where interoperability, we're not at that point where that's the blocking thing. right? Right now, the concepts from Beam SQL to Flink SQL map pretty directly, pretty well. But for example, yeah, if somebody were like, we're not going to have watermarks, we're not going to have these like windowing. I think right now you say group by, tumble, blah blah blah, and you can specify your windowing in that clause. And if we ended up standardizing on a syntax where we couldn't actually determine, there was no explicit windowing, but we had to sort of scrape from the sort of like, say, the semantics of like a having, it would be like the predicates in a having clause, in order to know when an aggregation is done or should be presented to the user or have its final output produced, or however you want to describe it. If we had to do that, then you know there's some work to do in an optimizer to be able to do that, and it may or may not. You know, I don't think there's anything that's going to be like feasible on one engine and not on another yet, but it's a risk, and that's why everybody is weighing in with their presentations of what they think streaming SQL should be like. I would say we're probably years out of having it in the real standard, but people who are actively working on streaming systems can talk to each other and should talk to each other openly and try to get to some agreement beforehand, right? We should, like, Insights is not the right place necessarily to have the debates about what streaming SQL should be. The right place is like, I don't want to, I'm not going to say market, but like in the wild, that's like building things that do streaming SQL and talking to other people who are building things that do streaming SQL, and just like, yeah, having a coffee or a pint and arguing with them about it, and eventually agreeing, and writing about it together, which I really, really enjoyed when I got a chance to do it. Yeah. Is that enough? That's enough rambling.
Calcite is a big help for this too, right? Because it kind of forces all of these different projects to talk to each other and maybe not standardize, but at least have a common language or a common set of tools for doing these things.
Yeah, that's totally true. And it raises a good point where Calcite has this group by tumble syntax. And, you know, we came up with this idea in the one SQL paper. We sort of had this other idea where we could use table valued functions, which they're just functions. There's nothing magical about them, but they signify that you're going to be manipulating timestamp columns that represent event time that could have a watermark associated with it. And so it's a different approach, and that came from Beam, I think, primarily, and has contributed. So I think now Calcite, you can do either of these using Calcite. And it's sort of, you know, they're both available. They're both in Calcite, and it's, I guess, in some sense, the place where the resolution of all of this might happen. And it's a nice sort of test bed because of having this very extensive open source implementation of both, you know, SQL parsing and optimization and mapping to lots of engines.
Perfect. I think that might be a good point to end on potentially. It is it's 20 past 7 here. I'm assuming it's about 20 past 11-ish, maybe, where you guys are. So we are moving on to our next lot of breakout sessions. A huge thank you to Ethan, Kenneth, and Kyle for everything for the entire session. If anyone has any additional questions that they would like to ask, you can head to event and select people and find our speakers and direct message them if you would like to. But that is the end of our session. So again, a huge thank you to everyone for joining us.
Thank you, Charlotte. Thanks, everyone.